Let's talk about rate limiting today. So with rate limiting, we limit the number of requests that can come into our application per unit time. Let's say like, 1000 requests per second, something like that. We limit the number of requests. And why do we need something like this? Well, there are few scenarios. The obvious one might be something like a DDoS situation. When an attacker attacks your application by bombing multiple requests from multiple IPs at the same time so that your application goes down, right? That's a bad situation. So with rate limiting, you can prevent your application getting any more requests than it can handle. And you can apply this basic principle in cases other than DDoS attack also. For example, if you have a public API and you don't want a specific API key to request the API more than their quota. Another interesting application was done by Hotstar actually, where they used rate limiting to not let you watch more than few minutes of IPL for free. Yeah. So the problem at hand is that requests are coming in and we need to implement some kind of function or component to allow the requests or not allow the requests, right? So to do this, let's try to have some, windows like this. Let's say first I want my capacity to be 4 requests per 5 seconds. So which means that for every 5 seconds, I don't want to let in more than 4 requests in my application. So what we can do, we can have like windows like this of 5 seconds each. So each window would represent 5 seconds of time spent, and we will keep putting these requests into the windows. And how we can do that? We can just simply divide the timestamp where it at which the request came by the window size. So for us, the window size is 5 seconds because our time unit for the capacity is 5 seconds. So we have kept window size of 5 seconds, and we will divide the timestamp by 5 and we'll get the bucket ID. So obviously which come in the first 5 seconds, they will have the bucket ID of 0 and then 1 and so on and so forth. And if we in one bucket we have more than 4 requests in our case, or whatever boundary that we have defined, if we have more than the threshold or if we have more than 4 requests, we would not let the 5th one come in, right? So if you see here, this time, the request coming in a timestamp 12, which is assigned to bucket 2, this already has 4 requests, so we would not let this come in. We would reject this request. As you might expect, because I'm starting the video with this approach, there is a problem with this. See, look at this 5 second mark, right? Look at this 5 second span. This can also be a window for us, right? But if you see in this 5 second span, we have let in 5 requests, which is a problem, right? We should not let in more than 4 requests. And let's say there is one more request here and we are considering this 5 second span, then also we are allowing 6 requests per 5 second in this case. This is happening because we are crossing this window boundary, and that's why we have this corner case where our algorithm right here will give us bad results. So as we can't have fixed windows of this size, let's take a sliding approach. Whenever a request comes in, we store its timestamp along with its request ID into some data structure, let's say like a linked list. And whenever a new request comes in, we will first remove all the requests that came in 5 seconds before it, in our case. Or to generalize, we can say which came in before the time window that we are considering. And to get that timestamp, we will just take the current timestamp minus the time interval, which is 5 seconds for us, plus 1. So that would be 2. So anything that came before this timestamp, we would remove them, right? So we see that we don't need this request because this is outside of the time window that we want to consider. Now we will check in the data structure how many requests we have. Now we see that we already have 4 requests for this time span. So we would reject the new one, right? So what we are doing here is very simple. We are removing all the requests that are beyond any window that we can consider, and then count the number of requests that we have in the current time span, and we are removing if anything extra is coming, or sorry, we are rejecting anything extra that is coming. Now this algorithm is a good one. It solves our problem that we were having, but there is still a problem. Storing these many requests, now obviously we have a 4 requests per 5 second, okay, my handwriting is so bad. 4 requests per 5 second boundary. But in real life, this can be, thousands of requests per some time span. So storing this many requests with the timestamp in the memory might be problematic. It will be even more problematic if you have a distributed system, So what do? We need to have something similar like this, but in a very space efficient way. So let's do one thing. Let's bring back the algorithm we had for the fixed windows that we are considering, our first algorithm. And let's consider we have a request at this time. So you can say this is the 7.5 second timestamp. So this is 2.5 second inside the window. So if this window is 5 seconds long, this point here is the 2.5 second mark, which means if we have covered 50% of the allotted time window that we have. Now if you see in the last 5 seconds, we actually have more than 4 requests. Even if this is the 6th request we are getting, we actually have like 5 requests that has come in. So should we reject or accept this one? So ideally we should reject this request if our algorithm is a correct one. But how do we detect this? Now we have spent the last 2.5 seconds gathering 3 requests. Let's say we include this. So in the last 2.5 second, we have got 3 requests. Now we need the number of requests for the last 5 seconds, right? But how can we get it? Let's do one thing. We take the previous bucket, and this is 5 seconds long, and we take the 50% of the total count of it. So we have already stored the total count of it, which is 3, and we take the 50% of it, which is 1.5. So what we are doing is we're assuming that the requests that are coming in the previous bucket are coming in a evenly distributed fashion. Now this might not be true, but we're taking this assumption to get a good enough approximate value for ourselves while keeping an algorithm quite fast and efficient. So if we need to get the amount of requests that we got in the last 2.5 seconds or half the time of 5 seconds, what we will do is we will take 50% of it. Now let's say the request came in somewhere here and we spent 70% of the allotted time of this bucket. We would take 30% of this previous bucket. So we would take the percentage what we have got currently, and we would take the remaining percentage from the previous bucket. This line sounded so mathematically bad, but you can think about it like this to understand this better, right? So let's add these two values. So from here, for these 2.5 seconds, we have got 3 requests. For these 2.5 seconds, we assume that we have got 1.5 requests. So that is 4.5, which is more than our criteria, right? So that's why we will reject this request. Now you will see that already 5 requests have been let in by our rate limiter, because see, due to this approximation, not only the algorithm can be more efficient, but due to this assumption, temporary spikes in the metric. So let's say our requests are coming like this, and there is a temporary spike. We would ignore these temporary spikes. We might sometimes let in more than our capacity in this way, but because these are not coming in for the sustained period of time, this shouldn't be a problem. So we would only let in more than what is required if there are temporary spikes in requests coming in, which is okay for most use cases, right? And as you saw, we get 4.5 and we reject this request. Now this final method which I described is called the sliding window technique for rate limiting, where we see that how much of the current time window we have spent, and then take the remaining amount for that time span from the previous window by taking a percentage approximation. And guys, with this you have a simple yet somewhat effective rate limiter. Thanks, and I'll see you in the next one. Bye.